So in this example, we are considering three matrices. We have matrix A, matrix B, and matrix C. And we're asked to find the following. In part A, we want to find matrix A plus matrix B. In part B, we want to find the sum of matrix B and matrix C. And then in part C, we want to find matrix B minus 2 times matrix A. So, before we even get started, the number one thing I want you to remember here is that in order to take the sum of two matrices, they must be the same exact size. So matrix A plus matrix B, for example, exists if and only if matrix A and matrix B have the same size. So that'll be essential for us to remember as we proceed. So here we go. Let's look at part A. Now in part A, we want to find matrix A plus matrix B. So let's quickly make a note of what are the sizes of these two matrices. Well, we can see that matrix A here is a 2 by 3 matrix. And we can see that matrix B is a 2 by 3 matrix. So they're equal. Woohoo! And we're ready to go. So finding the sum, we have matrix A plus matrix B. So matrix A is given to us with the column vectors 1, 3, 0, negative 4, negative 2, 2. And now we're adding matrix B, which is 7, 1, or has column vectors 7, 1, negative 5, negative 3, 1, negative 4. And so again, in order to combine these two matrices, we want to add up their corresponding column vectors. So this means we're going to have the sum of the first two corresponding column vectors. So that's going to be 1 plus 7. And the second entry will be 3 plus 1. Beautiful. So now we want to go ahead and add the second corresponding column vectors. So that's going to be 0 minus 5, and then negative 4 minus 3. And last but not least, we want to add the third corresponding column vector, which leaves us with negative 2 plus 1, 2 minus 4. And so we are left here with the beautiful final answer of 8, 4, negative 5, negative 7, minus 1, negative 2. And so that is the sum of matrix A plus matrix B. Beautiful. So now we want to go ahead and apply a similar method to part B. And giving ourselves plenty of room. So in part B, we are asked to find the sum of matrix B plus matrix C. And now again, to get us started here, let's simply think about the sizes of these matrices. So matrix B, we know, is a 2 by 3 matrix. And matrix C is a 2 by 2 matrix. So wait a minute, they have different sizes. So can we find the sum? No! Matrix B plus matrix C does not exist. Right? Their sizes are not equivalent, or they have different sizes. And that's it. If two matrices do not have the same exact size, we cannot find their sum. And last but not least, we want to go ahead here and find the sum of matrix B minus 2 times matrix A. So we already know that matrix A and matrix B have the same size. Right? We saw that in part A. A and B are both 2 by 3 matrices. So we know that their sum, this scalar multiple sum, is going to exist. So another way to think about this, matrix B minus 2A. We don't have matrix subtraction because of scalar multiplication. So another way to think about this is matrix B plus the scalar multiple negative 2 times matrix A. So let's start with that scalar multiple. Let's find the scalar multiple minus 2 multiplied by matrix A. So this is going to be negative 2 multiplied by matrix A, which has column vectors 1, 3, 0, negative 4, minus 2, 2. And now remember, we want to take our scalar multiple, negative 2, and distribute it through to each of the column vectors. So in other words, the columns of matrix A will be minus 2 times as big, or small in this case. So we have negative 2 times the first column vector, 1, 3. Then we have negative 2 times the second column vector, 0, minus 4. And then negative 2 multiplied by that third column vector, negative 2, 2. And distributing that scalar multiple through, we are left with the 2 by 3 matrix, whose first column vector is negative 2, negative 6, whose second column vector is 0, positive 8, and whose third column vector is 4, negative 4. Lovely. Now, the only thing here is don't get so excited that you found the scalar multiple that you forget the ultimate goal. We still need to go ahead now and find b minus 2a. Or again, remember, we're thinking about this as b plus this scalar multiple, negative 2 times a. So plugging in our values here, we have matrix B, who has the column vectors 7, 1, negative 5, minus 3, and 1, minus 4. And now we are adding the scalar multiple of a that we just found, which is negative 2, negative 6, 0, 8, 4, minus 4. So now it's just matrix addition again. So we're adding those corresponding column vectors. So we have the sum of the first two column vectors, which leaves us with 7 minus 2, 1 minus 6 for the first column vector. We then have the sum of the second corresponding column vectors. So that will be minus 5 plus 0, negative 3 plus 8. And last but not least, we want to add those third corresponding column vectors, which leave us with 1 plus 4 over negative 4 minus 4, for the beautiful final answer of 5, negative 5, negative 5, positive 5, positive 5, negative 8. And so there you have it. This is the beautiful final answer for B minus 2a.